TIS sensors use a similar logic structure in programming, with slight differences depending on the sensor function. This applies whether the sensor is a simple PIR sensor, a multifunction energy-saving sensor, an air quality sensor, an occupancy sensor, a weather station, or an analog input module. In the software, you can navigate between sensors and double-click any sensor to program it. In this example, we select a simple PIR sensor to explain the basic programming concept for TIS sensors. Select the sensor from the list and double-click it to open the configuration window. On the General page, you can write comments for the sensor. We recommend writing the sensor location for residential projects or the label or code for large commercial projects. This makes future maintenance and troubleshooting much easier. Since this PIR sensor also includes a light intensity sensor, you can later calibrate its lux value if required. You can also adjust the PIR motion sensitivity. Higher sensitivity makes the sensor more responsive, but it may increase false alarms or sensitivity to temperature changes in the room. We recommend setting the sensitivity between 85% and 96%. When you open the Logic tab, it consists of 4 sections. Section 1. Logic List. Section 2. Conditions. Section 3. Condition Status. Section 4. Command. In Section 1, you can browse logic numbers from 1 to 8 or 1 to 32, depending on the sensor type. Logic Status. Enable or disable the logic to make it valid or invalid. Logic Comment. It is very important to assign a clear comment to each logic so you can easily understand it later when reviewing your programming. Section 2. Conditions. In the Conditions section, you configure the conditions for each logic. Each sensor provides different inputs and condition options. Examples for a PIR sensor. Motion sensor. Set the condition to movement or no movement. Lux. Light intensity. Set a brightness range between 0 to 5000 lux. Flag. You can enable flag A and flag B and assign a value between 200 to 240. Flags are useful for advanced logic combinations, which will be covered in a separate lesson. Time. If a clock or gateway is broadcasting time, you can enable a time condition and define a time range for logic execution. Date or week. Some sensors allow logic based on a date period, while newer sensors use weekdays. This allows logic activation on specific days such as Monday, Friday, or other weekdays. Relation between conditions. The relation setting defines how conditions work together. If the relation is set to and, all conditions must be true for the command to run. For example, motion is detected and the light level is between 0 and 400 lux. If the relation is set to or, only one condition needs to be true for the command to run. Delay time. This time is set in hours, minutes, and seconds. It defines how long the condition must remain true before the command is executed. Example: if no motion equals 10 seconds, the command will execute only after no movement is detected for 10 seconds. Once all conditions are configured, press Save Logic. Refresh Logic updates the logic information by reading it again from the device. Set Function allows you to permanently enable or disable specific sensor functions that are not required. These functions can also be enabled or disabled using the universal switch command. Each function corresponds to a specific universal switch number. For example, the motion sensor function uses universal switch 255. Section 3. Condition Status. In this section, you can view the current condition status, the running time, which shows the remaining delay time before the command is executed, Other related condition states. Section 4. Command. This section allows you to view and configure the command that will execute when the conditions become true. Click Modify Command to edit the command.